On the stifling, humid afternoon of Thursday, the 12th of August, 1993, at the edge of a severely flooded drainage basin in Pulaski County, Illinois, a 34-year-old site foreman named Kevin Miller watched a $400,000 piece of modern engineering slowly disappear into the earth. The machine was a nearly brand new 40-ton hydraulic excavator, and it was currently buried over the top of its steel tracks in deep, merciless black clay. Standing on the solid gravel service road 50 yards away was a crew of 4 men from a commercial heavy lift recovery company out of St. Louis. They had been on the site for 10 grueling hours. They had brought 2 massive twin-axle heavy wreckers equipped with 50-ton hydraulic winches, and they had just officially given up. The lead recovery engineer, a man who charged $300 an hour for his specialized expertise, stood by his pristine truck and told Kevin that the excavator was dead. He explained that the immense suction created by 40 tons of steel buried in wet Illinois clay effectively doubled the machine's dead weight. The hydraulic winches on the modern wreckers had simply spun their heavy rubber tires on the gravel, completely unable to find enough traction to overcome the suction. The engineer declared that the only way to save the excavator was to wait until late September for the ground to dry into concrete, dig it out by hand, and drag it out in pieces. He wasn't guessing. He was reading the absolute mathematical limits of his modern equipment. When the recovery crew began packing up their heavy steel cables, an old man in a faded denim jacket stepped out of a rusted pickup truck that had pulled up unnoticed on the county road. His name was Arthur Vance. He was 74 years old. He looked at the sunken excavator, looked at the frustrated modern engineer, and quietly offered to pull the machine out before the sun went down. The recovery crew didn't just dismiss him, they laughed out loud. Arthur didn't have a modern $500,000 wrecker. He only had a rusted, 35-year-old piece of iron sitting on a heavy transport trailer down the road, but their laughter relied on a fundamental assumption about how force is applied to the earth. They were reasoning from horsepower. Arthur was reasoning from ground pressure. To understand exactly why the recovery crew felt so comfortable laughing at the old man, you have to understand the brutal, uncompromising physics of a deep mud extraction. The commercial recovery engineer wasn't a fool, and his equipment wasn't cheap. He had brought 2 state-of-the-art heavy wreckers. Combined, they possessed over 1,000 horsepower and immense hydraulic pulling capacity. But pulling a 40-ton excavator out of a wet clay trench is not a matter of raw engine speed. It is a matter of static suction and mechanical traction. The moment the wreckers had applied tension to the cables, the sheer drag of the clay essentially turned the 40-ton excavator into an 80-ton dead anchor. The wreckers, sitting on rubber tires on the gravel road, simply did not have enough contact area with the earth to transfer their immense engine power into a sustained forward pull. Their tires lost traction, spun wildly, and burned thick black rubber against the stone. No matter how much hydraulic force the winches could generate, the trucks themselves couldn't hold their ground. The engineer knew the math. The suction was too great and the traction was too low. The machine was fundamentally trapped until the earth decided to release it. The idea that a 74-year-old local farmer was going to achieve with a single antique machine what 2 modern purpose-built recovery trucks could not do was, to the modern mind, mathematically absurd. If you've ever watched a modern crew pack up their expensive gear and declare a job impossible, only to see an old man with a rusted machine quietly get to work, or if you've been the one holding the grease rag, this story is for you. Walton's Iron is where these records are kept. Subscribe and stay with us. Because sometimes pulling a machine out of a swamp isn't about how fast your engine spins, but about how hard your tracks grip the earth. Now, let me tell you what Arthur Vance actually knew. Let me stop here and tell you about the Caterpillar D9G, because this story isn't really about a modern excavator getting stuck in the mud. It is about a piece of machinery that was built for a world that required mountains to be moved. In the late 1950s, the United States was undertaking the largest public works project in human history, the interstate highway system. They needed a machine that could carve through solid rock, push massive amounts of earth, and operate relentlessly in environments that would destroy ordinary equipment. They didn't need delicate electronic sensors. They didn't need speed. They needed pure, brutal, unyielding mass. The Caterpillar company answered with the D9G crawler tractor. It was an absolute leviathan of forged iron and steel. It was powered by a massive turbocharged diesel engine that produced nearly 400 horsepower. But more importantly than the engine, the D9G weighed a staggering 80,000 pounds. To the modern engineer staring at his rubber-tired wreckers, weight was a liability that caused machines to sink. But to a track-laying vehicle, weight is the very source of its power. The D9G didn't use its engine to spin tires quickly. It used its engine to turn massive internal final drives, translating that horsepower into pure torque. And it distributed its 80,000 pounds across a continuous track of heavy steel plates, creating an immense footprint. While the modern rubber-tired truck sat on the surface of the gravel and spun, the 1958 Caterpillar D9 was designed to grip the earth like a heavy iron fist. Arthur Vance hadn't brought a fast machine to the trench. He had brought a machine that simply refused to let go. The recovery engineer had laughed, but the site foreman, Kevin Miller, was desperate. His excavator was sinking an inch an hour into the slurry, and by tomorrow morning, it would be utterly unrecoverable without a massive secondary excavation. He told Arthur to back his trailer up to the trench. Arthur didn't boast. He didn't promise a miracle. He simply backed up his rusted truck, unchained the massive 1958 Caterpillar D9G, and started the pony motor with a sharp crack that echoed across the flooded basin. The main diesel engine roared to life, blowing a dense column of dark soot into the humid gray sky. Arthur didn't drive the D9 to the edge of the trench. Instead, he drove it 50 yards in the exact opposite direction, stopping the massive crawler near a stand of mature, deeply rooted oak trees. The modern crew watched in utter confusion as the old man climbed down from the steel seat. Arthur wasn't planning on dragging the excavator out with a straight, direct pull. He knew that even the 80,000-pound crawler couldn't defeat the suction of 40 tons of wet clay in a simple tug-of-war. Instead, Arthur walked to the back of his pickup and pulled out two incredibly heavy, rusted iron snatch blocks, a traditional multi-sheave pulley system. He chained one massive pulley to the base of the largest oak tree. He walked down to the trench and handed the end of a thick 1-inch steel cable to Kevin, instructing him to hook it directly to the heavy undercarriage of the buried excavator. Arthur was rigging a mechanical advantage. By running the cable from the excavator back to the tree pulley, through a second pulley on the D9's massive drawbar, and finally anchoring it back to the tree, he was using basic physics to multiply the pulling force of his machine by a factor of 3. The modern wreckers had tried to fight the mud with speed and raw hydraulic pressure. Arthur was going to fight it with geometry. Arthur climbed back into the heavy steel seat of the D9G and eased the massive master clutch lever forward. The Caterpillar didn't lurch, and it certainly didn't spin its tracks. It simply leaned into the heavy steel cables. The modern recovery crew watched, fully expecting the old tractor to stall or its tracks to break traction and spin uselessly on the gravel, just as their $500,000 wreckers had done. But the D9's continuous steel tracks distributed its 80,000 pounds over a massive surface area. It didn't break the surface tension of the earth. It locked into it like a heavy iron vault. Through the rusted block and tackle system, the D9's massive torque was being steadily multiplied. For a long, agonizing 2 minutes, absolutely nothing seemed to happen. The thick steel cables vibrated with terrifying lethal tension, hovering perfectly rigid above the mud. The old diesel engine dropped into a deep lugging register, the exhaust stack blowing a solid, continuous stream of black soot as the governor demanded more fuel. The massive crawler was pulling with a force that would have snapped the modern wrecker's cables in an instant. And then, from the bottom of the flooded trench, a terrible, wet, sucking sound echoed across the basin. It was the sound of a vacuum breaking. The black clay, which had completely defeated raw hydraulic speed, was slowly yielding to relentless, multiplied torque. The massive, buried excavator shuddered violently and then, inexorably, began to move. Inch by agonizing inch, the 40-ton excavator began to drag forward out of its grave. It wasn't fast. The old D9 crawled at a pace of barely half a mile per hour, its massive diesel engine throbbing with a deafening, rhythmic percussion that physically shook the ground where the modern crew stood. But it never stopped. The massive iron pulleys groaned under the extreme load, their greased bearings whining as they perfectly translated slow, steady forward motion into irresistible lifting force. After 30 grueling minutes, the massive front steel tracks of the modern excavator broke the surface of the slurry and bit hard into the solid gravel bank. The suction of the clay was completely broken. The $400,000 machine was dragged completely out of the trench and onto safe, dry ground, dragging a mountain of wet mud with it. Arthur Vance pulled the heavy master clutch lever back, idling the roaring D9 down to a quiet, shaking rumble. The recovery engineer walked over from his pristine truck, staring intently at the rusted iron pulleys, the taut cables, and the meticulous geometry of the rigging. He didn't offer a dramatic confession of his own arrogance, and he didn't throw a tantrum. He was a professional who respected the absolute laws of physics, and he had just watched physics behave flawlessly in the hands of an old farmer. He took off his hard hat, looked at the old man wiping grease from his hands on the steel tracks, and simply admitted that the math was undeniable. The highly paid heavy lift experts had brought speed and raw hydraulic pressure to a problem that fundamentally required mass, patience, and geometry. Arthur Vance didn't gloat. He simply nodded at the engineer, walked back to the trench, and quietly began unhooking his heavy chains from the oak tree. But the undeniable victory of that afternoon had an honest limit. The 1,958 Caterpillar D9G was not a universally superior machine for modern daily recovery work. It had no enclosed cab, no climate control, no joysticks, and no precise hydraulic articulation. It was deafeningly loud, consumed fuel at a staggering rate, and operating it for 10 straight hours on rough ground required immense physical strength just to pull the steering clutches. The modern rubber-tired recovery wreckers sitting on the road could drive down a highway at 60 miles an hour, reach an overturned semi-truck, and execute a fast, clean recovery in a fraction of the time it would take the old crawler just to be loaded onto a transport trailer. For 99% of modern towing and recovery tasks, the antique crawler was completely, utterly obsolete. The commercial engineers were not wrong to rely on their modern, fast hydraulic fleet, but Arthur hadn't brought the machine to tow a truck on a highway. He brought it for the 1% of situations where modern efficiency fails, where speed is actively a detriment, and where all that matters is a machine's sheer, uncompromising refusal to let the earth win. The old way didn't work because it was magical. It worked because it was built for a singular, brutal purpose that modern engineering had engineered right out of its own equipment. Decades later, commercial recovery companies adopted even larger, computer-controlled hydraulic winches with synthetic lines to manage impossible pulls. But Arthur Vance's 1,958 Caterpillar D9G didn't go to a scrapyard. Today, it sits quietly in a well-maintained heavy equipment shed on the Vance family property. Arthur has long since passed, but the massive iron machine has not frozen in time. Every spring, his grandson starts the pony motor, engages the main diesel, and drives the massive crawler out into the sun, keeping the heavy oil moving and the iron alive. The most reliable advantage a person can carry into a crisis is not a $500,000 price tag, and it is rarely the absolute newest technology. It is a fundamental, quiet understanding of the exact physical mechanics of the problem in front of you. The world is full of modern solutions that rely heavily on speed and high pressure, waiting to be completely humbled by someone who simply knows how to grip the earth. Every story doesn't make the record. It does here. Walton's iron story's worth keeping. If this story meant something to you, if you grew up around heavy iron like this one, or if you know someone who did subscribe, because there are more stories like this one, and they deserve to be told while the people who live them are still here to tell them. If you've ever watched a piece of old iron do something the experts said was physically impossible, leave it in the comments. I read every one. And the mechanics of keeping those massive old machines alive, that's the next story we're going to tell.